this that we talked about in class. It's pretty standard. The way I'm going to do it is I'm going to solve, first let's roll what I had before. So if I solve for z here, I can have z is going to be, I'm going to write like 1 over 5 of 1 minus parentheses x squared plus y squared, right? I can solve it like that. So I'm going to do as we have done in almost a quarter long. I'll never directly use polar. I'm using a parameterization for this. So what I'm going to do is parameterize the unit disk in the ground, and then the z value is going to be just this value evaluated on those z-scores. Okay. Okay, let me see if I can do this. So I'm going to write phi of st is going to be nothing else but s cosine t for the x value, s sine t for the y value. Right? That way, when s goes from 0 to 1, this gives you the whole disk in the xy plane, and t goes from 0 to pi. And then on the z value, I just give you what the z is up here, right? But then since x and y are already given, this becomes s squared cosine squared plus s squared sine squared, so this becomes s squared. So this really is just going to become 1 over 5 of 1 minus s squared. Right? Because if you write x squared plus y squared, where this is your x and this is your y, you get s squared. Okay. Okay, so that's my phi. Let's find the normal. I do need to find the normal, so let's find who is phi s. So the phi, oops, I need a pen. Phi sub s is partial of this guy with respect to s. It just gives you cosine t. Partial of the same component with respect to s just gives you sine t. And the partial of the third component with respect to s gives us negative 2s over 5. Okay. Now let's do phi t. So this would be negative s sine t. This guy would be s cosine t. And this guy would be 0. So I hope you can see. I have to dig the zoom in so to write in my tablet. But that's what the work I was doing. So okay. And now I need to find normal. So the normal is just phi s cross phi t. So let's find that guy here. So the normal is nothing else but, right here, so I know where I am. So the normal is nothing else but the cross product of those two guys. So my first cross product is sine of t times a 0, which is 0. Then I have a negative. So I really end up having the positive, right? 2s squared over 5. So it's 2 fifths s squared cosine t. When I do the second component, I get similar. I get a positive, right? I'm going to get this times that is going to be, I have a true negative, so I'm going to multiply this guy times this guy in the bottom. So I get 3 negatives, so I get negative times negative. Am I getting negative times negative? Sorry, I get positive. I get this times that, so I get positive. So I get 2 fifths, again, s squared, and now I get a sine t. And my third component is going to be this term times that term, which is s cosine squared. Here I have a double negative, so it's plus s sine squared. So at the end, that is just s, right? So I have s times cosine squared plus s times sine squared, so it's just s. Okay, so that's my normal. So what I need to find the curl dot n. So I need to find the curl of this guy. So let's go and try to find the curl of this guy. Let me try to do it over here. So that's my parameterization. Let me find the curl over here. So I'm going to write how do we calculate the curl? Let's see if I can do this a little bit clean, this corner right here. So I'm going to write my f right here because we really don't see it, right? So I'm going to write my f was xz, comma, yz, comma, x squared plus y squared. So I'm going to find the curl of this vector field. which is a little bit of a pain to write all this notation. E1, E2, E3. I find a partial x. I have to write my nabla. Partial y, partial z. And what I'd write down here are those things. Xz. So my f entries, right? So remember the curl is, this is a neat way to calculate it. It's just like the nabla cross f. What that means is you apply the operator's partials to these functions. So when I take the partial of this guy with respect to y, I get a 2y. And I do the partial of this term with respect to z, I get a y. So the first component turns out to be 2y minus y. Then I'm going to do the second one, which means I'm doing, let me erase these guys. It's get too confusing. So now I'm going to do, what if I change that to red? I'm going to do the partial of, I'm doing the second component, so I'm doing the partial z of this, which is x, minus the partial of x of this, which is 2x. So I get x minus 2x. And my third component is 0 because I need to do now, let's see if I can change the color. So I need to do the partial of this guy with respect to x, which has no x, so it's a 0, and the partial of this guy with respect to y, because I'm doing this one, right, which has no y, so it's a 0. So my third component is just a 0. Okay. So that's my curl. Okay, what do I need to do now? I have all what I need, right? I need to do curl of f dot n. I have the curl of f here. I got dot n. I do need to do one more thing. This is in terms of y and x's, my curl. I need to write in terms of s and t, correct? So I need to do one more thing. I need to write who is the curl of phi of the surface. So let me write that down. So I need to write, I'm going to write it here. Let me write a big line here and say, now I'm going to do who the heck is the curl of f but evaluated in phi. Well, that guy, I just copied the parameterization. So it's, well, let's simplify this. This is just negative y, right? So it's just, the first component is just negative y. And this is just, sorry, the first component is just y. And the second component is just negative x, correct? I didn't simplify that. So then this first term is just a y, but y was in my parentheses s sine t, right? So here I would write s sine t. And then it's negative x, so this guy would be negative s cosine t. And my third component is 0. Okay, and now what I need to do is find, I'll do it right here. Sorry, it's a little bit of all crammed here, but space is important here. All I need to do now is find nabla cross f, evaluate phi, I already have that, dot n. Well, I have those two guys right here. Right, I'm going to do the dot product of these two terms, and grab a different color here. I'm going to do the dot product of this guy, which is this, with n, which is this. Okay, so it's not going to be terribly complicated because I'm going to see what I'm going to have. The first term is going to be, I'm going to write it right here to make it small, but you see that what I'm going to get? I'm going to get 2s cubed over 5 sine t cosine t. So this guy here got erased. But the second term becomes the negative of the same thing. 2, sorry, it should be a 2. Negative 2s cubed over 5 sine t cosine t. So these guys cancel. Sorry. There you go. The third term is 0, right? Because I have a 0 entry right here. So there you go. That is 0. Yeah. So I don't have to do any integral. So this was a lot easier than we thought. We're doing a lot of work, but at the end of the day, I have to do no integral because these guys cancel. Yeah. So let me show you that in a bigger here. What happened was I'm doing the dot product of this, right, with this up here, and they cancel because this has a negative. That's important. This negative is going to make these guys have the opposite signs and they cancel. Okay, so that means that this side, right, the integral that I wanted to find over here, let's go up here. This side of the integral that I wanted to find is 0. Let's find this other side and see that, well, it should also be 0, right? Let's find out. So let's do that one down here. Okay. So for that one, I need to do, I need to find out who is the parameterization of the curve, but like we said before, that is just a unit circle, right? So I'm far down, so I'm going to copy again who is the f. So you can probably see it in your notes, but it's hard to follow here in the video. So I'm going to write again who is the f. So my f was just xz, comma, yz, comma, x squared plus y squared. And what I need to do now is find who is curve gamma for this, for my boundary, and that's just a unit circle. So I need cosine t, sine t, 0. I want the unit circle on xy plane, right? And I need, of course, t in 0 to 2 pi to have the whole circle. Okay, so I need to find tangent, so gamma prime, which is negative sine t, cosine t and 0. Okay, and let's find who is f of gamma, right? Because what I need to find is f dot gamma prime, correct? So let's find who is f of gamma. So f of gamma, so this is f, right? So f evaluated at gamma would just be, let's see, it's xz. Z is 0 for my gamma. So that is 0, right? My first component here is 0. Second is yz. Well, for the same reason that's 0, because in my gamma, the z is 0. And my third component is x squared plus y squared, which in this case is just a 1, right? If I use f of gamma, so this is just a 1. Okay, so what I need to integrate here is I need to integrate from 0 to 2 pi. I need to integrate f of gamma dot gamma prime. But, well, that's a 0. Because if you take the dot product of these two guys, this term is 0 times that, so it's a 0. Then 0 times this is 0. And then 1 times 0. So this integral that I have right here is basically a sum of zeros. So it's also 0. So we're done. We didn't have to do any of the integrals in the original problem. Both of these sides are 0. So that's it. Okay, I hope this kind of makes sense. I'll probably do another example where we do have to do some integrals.